we'll see the methods of integration. So, how to find out the integrals? First is by inspection. We just need to find out that if this is the derivative, what would have been the original function. This is done by the inspection. For various functions we can find it out. Then we'll try to find out the more advanced way of solving it, that is integration by substitution, integration by partial fractions, integration by parts. Integration by substitution. How? If you are given an integral fx dx, we can change it, transform it by putting some variable x with t, by substituting x equal to gt. When we find the differentiation of this, dx by dt is equal to g dash t. So what gx will be? Take this dt here. Dt will be nothing but g dash t dx. So for this x we will put gt in this, and for this dx we will put g dash t dt. So this change of variable is very important tool in order to find out the integration by substitution. And here we'll see that a somewhat looking difficult integration will become so easy. If you are not able to understand this, let us take some examples. We want to integrate this. See, first one, sine mx. If I give you sine x, you will promptly say, I know the integral of this, but how about this mx? For that, what we'll do, we will want some t or x here, t or any, then we can easily find out the integral. But when mx is there, we can convert it into some t. So what we'll do here is mx will take it as t. What will be mx equal to t if we have taken? Let us take d by dx both sides. This m is constant, so it will come out. d by dx of x is 1. This will be dt by dx. Take dx here. So dt will be m dx. Right? So this sine mx dx will become what? Because we have taken t. We have taken t here. So it will be sine t. And for dx, we'll write what? dt by m. dt by m is nothing but dx. For this dx, we'll write dt by m. M will come outside. Sine t we know. This is minus cos t. Okay. This 1 by m remains here. But t we have assumed to be mx, so we have to replace it with the original. So we'll replace this t with mx. Our integration became easy. Similarly, for this one, if we place x square plus 1 as t, dt will be 2x dx. You differentiate this side. So this will become, this 2x dx will be dt, and this will be, because we have assumed it to be t, this will be sin t dt, and again sin t is simple, minus cos t, and then we'll again, t will be replaced by x square plus 1, so it will be minus cos x square plus 1 plus c. Similarly here, if we want to find out the derivative, this root x, which is nothing but this, if you differentiate it, it will be half x to the power minus half, that is 1 by 2 root x. So let us place root x as t, differentiate it, this will be 1 by 2 root x dx dt. Now what you can do here is, you can take this dx here. So this will be, dx will be 2 root x dt. But root x we have taken t, so it can be written as t, 2t dt. Now let us take this. What we have taken? Root x as t. So this will be 10 to the power 4t sec square t, this is t. And how about this 2t dt? This dx is nothing but 2t dt. But this t can be cancelled out and 2 can be taken out. Now we are only left with 10 to the power 4t and sec square t. Here again we'll make substitution. We'll take tan t as u. So when you take du by dt, this will be tan t will be sec square t. We will take dt here. So d will be sec square t dt. So this becomes what? This we have taken as u. This is nothing but, see, this whole this whole will be du. So this will be u to the power 4 du. And we know the integration of this to u to the power 5 by 5. Now u we have taken as tan t, so replace it by tan t. But t we have taken as root x, replace it by root x. This is your final solution. And don't forget about this c. How about this? We know that when we derive or derivate tan inverse x, it will be 1 by 1 plus x square. So if you take tan inverse x equal to t, dt by dx will be 1 by 1 plus x square. Take this here, means dt, dx here. So this dx by 1 plus x square becomes dt. And this becomes tan inverse is t. So this will be sin t. Sin t we know minus cos t. T can be replaced by tan inverse x. This is how we solve it.